In this video, I would like to discuss on the continental drift hypothesis, and which ultimately led to the plate tectonics theory. So, how or what is this plate tectonics theory all about? I may not be going into the full details of it, but how it has emerged and what is the whole concept and what is the background behind the whole thing. So, continent drift hypothesis and plate tectonics theory. So, in fact, when we study in geography, we always talk about geomorphology is a very important component of geography. Geomorphology, geo plus morpho plus logy. That means geo is earth, morpho is form and logy is science. So, the earth form science, what is there on the surface of the earth. So, whatever we see on the surface, all the landforms, we are actually talking about the landforms. So, one of the major study matter or other what are the major components of what we study in geomorphology is the formation of various landforms and what is the reason, how has it formed and how is it modified, is it permanent, is it non-permanent, all these questions are always raised. In fact, according to scientists, any landform on the surface of the earth is a result of endogenetic as well as exogenetic forces. Any landform is a result of endogenetic and exogenetic forces. So, those forces from within, from the interior of the earth and those forces from the exterior of the earth. So, any movement in the interior or any force in the interior of the earth or any force from the exterior like running water, wind, glaciers, waves, all are exogenetic forces or these are resulting in modification of the landforms on the surface of the earth. But if you look at the history a bit, we were not very sure about these kind of forces and all maybe even 100 years before. In fact, till 20th century, the concept was that all the landforms on the surface of the earth are permanent, the permanency of landforms. Permanency of landforms, meaning whatever we are finding or whatever we see on the surface of the earth, they are permanently there. If Himalayas are there where it is today, the understanding was that it was there right from the beginning, right from the formation of the earth, right from the beginning, these Himalayas were there where it is. So, there was no concept of this might not have been there or it might have emerged after some time. There is no concept of evolution of a landform and then maybe final destruction of the landform. This concept was not there. So, everything or everybody thought or most scientists or most geographers thought that all the landforms or the continents where they are, the present continents are there where they are and it was there right from the beginning. The oceans were there right from the beginning. So, that was the kind of concept which was there earlier. But this permanency idea was questioned by some geographers and geomorphologists, and by early 1900 a German geographer or we can say climatologist and geomorphologist Alfred Wegener, he came up with the concept of non-permanency. There were some geographers earlier, but their ideas were discarded outrightly. So, Alfred Wegener, a German climatologist and geomorphologist, he was the first to forcefully present the idea that the continents were not permanent, oceans are, he did not talk about the oceans, but he talked about the continents in a big way. And he came up with a hypothesis called continent drift hypothesis. Continent drift hypothesis. So, he gave his ideas in 1912 and later on he published a book in German in 1915, and finally his German write-up was translated into English in 1924 into English. So till then, initially when he gave the lecture, then when he published the book, since it was in German, not many people outside could understand what he said, but finally when it was published in English in 1924, all hell broke out. The rest of the geographers and scientists outrightly rejected this idea. Many even called that Wegener has gone mad. Otherwise, how can you tell like this? Because the established understanding about the landforms on the surface of the earth at that time is all landforms are permanently there where they are. There is no concept of these continents moving or landforms evolved, nothing. So naturally his ideas were outrightly rejected. But let us see what is that continental drift hypothesis given by Alfred Wegener in 1912, which he tried to modify and improve and come up with more ideas. So according to Wegener, his hypothesis, he said around 300, so let me talk about his hypothesis. He said around 300 million years ago, it's a very simple thing he said, around 300 million years ago, all the continents were together, and he said by and large all the continents together, a supercontinent was there, and he called it as the Pangaea. And the supercontinent was lying or rather located somewhere in the southern hemisphere, near the south, in and around the South Pole and the southern hemisphere. And there is one super ocean, the Panthalassa. Panthalassa, the super ocean, and Pangaea, the supercontinent. That is what he proposed. And then he said that by around 200 million years ago, these continents started breaking down. So they started breaking into various pieces, and they started moving in different direction. So breakup of the continents started taking place. These continents started breaking down or breakup of the continents from the supercontinent Pangaea, and after breakup these continents started drifting away from the original place, and they drifted and reached the present location in the last 200 million years. The third point is they started drifting away, they started drifting and drifted to reach the present location in the last 200 million years. So according to him, if I show you one map, so it is said that he said all these continents were together. All these North America, Africa, the Laurasia, the northern continents were known as the Laurasia. Laurasia, Laurasia. And the southern continents put together, it was known as Gondwana. Gondwana, near the South Pole, and you can see, and in that time the South Pole or in and around the South Pole it was located. Antarctica was there, South America was there, Africa's portions were there, India was there, Madagascar is here, you can see in between Madagascar, Australia. And what is written here is this Pangaea, if it is reassembled. So and you can see the direction and the drift of the movement. He said these continents drifted away, and the direction and the drift of the movement is also given. So it drifted away. So around 300 million years ago, these continents were together. You can see that all the continents together. Around 200 million years ago, it started breaking away, and it started drifting away from their location, and drifted and slowly moved and reached the present location. And that is how these continents are. So another map, if I show you, so you can see this, sorry, please see, this is what around 225 million years ago, this would have been the location. You please see, around 225 million years ago, you can see this location, 225. And you can also see that India, you can see India is here, Madagascar is here, the rest of the shape we can easily see this. Then further around 180 million years ago, you can see this Laurasia, the northern continents, the North America and Asia, Eurasia, South America, Africa and all the rest, the Gondwana land, south, around 180 million years ago, the shape. And further, you can say around 135 million years ago, complete separation, India was moving. You see India's movement. And South America is also moving away from Africa. And similarly, we can see, you please see this, around 65 million years ago, South America also completely got separated, Africa is separated, India in its epic journey, and finally you can see this now after in the present location. So you can see it further moved away and the present continents emerged the way it is there today. So the idea, or rather the continent drift hypothesis, was given by Alfred Wegener, and he suggested that these continents drifted away. Now naturally when he said this, many asked questions. They asked, where is the proof, and what are the evidence for this? So immediately the Wegener started giving evidence. So he immediately gave evidences to his hypothesis. First evidence he gave is the fit of the continents. He said, you fit all the continents back, you can see a nice fit. That itself is the proof that these continents were together. But many scientists said that the coastline is changing, or rather we know that suppose a land area is there, and if there is a river flowing and if the delta is formed, it will increase the land area, or it will deposit things in the mouth of the river, and the shape of the land will, the coastline will change. And now if it is meeting, or if it is by and large matching, it may be a mere coincidence. That is what the critics said. The critics did not want to believe it when he said fit of the continents, that means continents can fit together. Many critics said that it may be a mere coincidence. You can see the fit of the continents here also in near the South Pole. This is where you can see the ice caps. So even India was under the influence, or rather covered by ice caps when we were near the South Pole. You can see the ice caps here, or this is another, this one, it can be easily fitted into the whole thing. That is the biggest evidence he suggested. So the first evidence gave by Alfred Wegener is the fit of the continents, even though the critics rejected this idea because the coastline is not permanent, it is dynamic. Coastline is dynamic. So his idea that the continents can fit together, they said it could be a mere accident, that accidentally we are able to fit it. Then the second evidence given by him is the rock type similarities. He said rock type similarities. So his argument was that if in a massive continent like this, if it breaks away, so suppose it is broken like this. Now when it broke away, and if you try to fit it back, you can see, suppose a particular type of rock was found in this particular region, say a particular type of rock. So this half of this rock will go in this continent and half of them will go in the other side. So if you fit it back, we can see a nice fit, or rather it will gel well. It's something like a torn paper, a newspaper, a torn newspaper. If you try to rearrange it, or a picture puzzle, if you rearrange it, and if it gives some sense, or if it is a continuity is there, then we can say we arranged it properly. The same way, if the rocks are coming at the same place, see, in fact, he gave evidence. So you just see this. He gave evidence for the rock types in North America and Africa. When you fit it back, you can see similar rocks are found on either side of Africa and North America, or even in Iceland and in England, or even Greenland and in the Scandinavian region, you can see similar type of rocks are found, and it is matching well. There is no mismatch when you fit it, and if two different types of rocks are found after matching it, then it would have been, we are fitting it wrongly. But he said, you see the rock type similarities on either side of the continents, that also can be an evidence. It's a solid evidence, but the critics did not want to believe in all these things, so they rejected it. So rock type similarity was his second evidence, and a third evidence he gave, it was related to the fossil evidence. The fossils, see, we are talking about the continents breaking away and then drifting away. It broke away around 200 million years ago, 225 million years ago, or 200 million years ago onwards, it started breaking away. So those plants, or even those smaller animals which are found in one continent, if it is found in many, if the fossil evidence is there for the same animal or same fossil of the same animal or same plant in two different continents or three different continents, Wegener said this is possible only if they were together at some point of time, then they broke away and went away. That is why you are finding the fossils in two different continents far away. Suppose you find fossils of same animal or same plant in in South America and in say Australia, which are placed thousands of kilometers away. How can there be the same animal in two continents? There cannot be parallel evolution, because evolution itself is it is a result of many factors which cannot be recreated in another place. So he said, if you find the same fossils in two different continents, the only reason is these two continents were together. So he gave evidence and example of many such fossils, and I can show you some of them. See, for example, just see this. The fossil of Cynognathus. See, it is remains of Cynognathus. It's a reptile. It's a land reptile, approximately 3 meter long. It is found. Now, where all is it found? You see, it is found in South America and it is found in Africa. See, both are found thousands of kilometers away, South America and Africa today. And now, when the continents were together, according to Wegener, they would have been living in this kind of a belt. They would have been living in this belt, and that is why we are able to find the fossils in two different continents at the same time. Similarly, we have evidence for another. It's a plant, a fern called Glossopteris. 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 It's a fern found in all the southern continents. Glossopteris is found in all the southern continents. You see, it is found in Australia, it is found in Antarctica, it is found in India, in Madagascar, in Africa, in South America, everywhere, Glossopteris. And another animal, you can see this. Fossils of these animals. This is a fossil evidence of a Triassic land reptile, Lystrosaurus. See, Lystrosaurus is found in India, the evidence, it's a Triassic animal, it's a reptile, it is found in India, it's the evidence in India, in Antarctica, in Africa. How is it possible? How can there be the same animal in three different continents which are far apart? The answer, according to Wegener, is these continents were together. That is why these fossils are found spread across three different continents. Otherwise, these animals cannot travel at that time. Human beings were not there at that time. Otherwise, we could have said that human beings might have carried from one place to another. Today we can say any animal in one place can be found in another continent also, maybe because we carried. When the voyages started, we carried them. But that is not the case here. They are not. Because 200 million years ago, 225 million years ago, or 300 million years ago, fossils. How is it possible to be in 3 different continents or 4 different continents? Wegener said the only answer is these continents were together. So he gave many evidences like this. Even he gave paleoclimatic evidence. He also gave what you call paleoclimatic evidence. A fourth evidence is related to what you call paleoclimatic. Paleo means old. Paleoclimatic evidence. See, that means old climate evidence. See, what we are saying is that we have evidence for, just see this, we have evidence for glaciation, ice, glaciers in India. We have evidence for glacier in entire Antarctica, glaciers in southern Africa, South America, in Australia. How is it possible? That means if India like country which is very close to equator, if you find a glacier in India, that means earth should have been very cold. So near equator, if earth was permanent, for a second if you believe that the continents were permanent, and if there are glaciers, if you are finding permanent ice near equator, that means earth should have been very, very cold. But at the same time, we have evidence for swamps, marshy land in North America, in Northern Asia, marshy lands. At the same time, when there is glacier evidence in India, there is evidence for swamps and marshy lands in Northern America and Northern Asia. How is it possible? How can equator be cool and the polar region be warm? So there is no answer. But Wegener said, I have an answer. The answer is all the continents were together. So Wegener's argument is all the continents were together in southern hemisphere. Just imagine all the continents were together say something like this. And when this continent started drifting away, what was near the equator, it has reached near the poles right now. And what was near the polar region, like in India, when India reached here, so it has become the ice caps or evidence for glaciers near the equator right now and the swamps near the polar region right now, because the continent drifted away from that time. See, so this is the old climatic evidence. The paleoclimatic evidence means old climatic evidence, whereby Wegener could explain why the ice caps or what you call the swampy land near the polar region right now. He said these swampy lands were near equator at that time, but it got drifted and reached the polar region right now. Similarly, if ice caps or the ice bound land which is found near equator right now, if it is near equator, it is because when it was formed, it was near the polar region. Now it has drifted to the equatorial region. So anyway, so these 4 evidences were given by Wegener, but his ideas were not acceptable to most of the scientists at that time. They discarded him. He rejected his ideas, but poor Wegener had no choice. Then he was asked another question. Then the people asked only one question to Wegener. Okay, if at all we agree that yes, the continents drifted, what is the driving mechanism? What is the driving mechanism? Who is driving? Where is the energy? Who provides this energy? Driving mechanism. So for this question, Wegener had no answer. Wegener pleaded and said that, see, I don't know. You will have to help, because I know that continents are moving. But he tried to give some evidence, but all these evidences were completely wrong. He tried to suggest that it could be because of the tidal force. He said, this could be because of the tidal force, the force by the tides. when this the high tide and the low tide takes place, because the attraction of sun and the moon, water hits the continent and the continents may be pushed. But naturally, that is the wrong assumption, and he could not say anything. I mean, it was outrightly rejected by the rest of the physicists. They said this is not possible. Tides have no such energy to push a continent, so his tidal force was rejected. Then he started talking about the continents cutting through the ocean floor like an ice cutter moving in ice in the colder regions, or in the the frigid regions, like an ice cutter moving. So he was saying on the smooth ocean surface, continents are able to move on the surface. Again, there is no evidence, and what he said was not correct. Today we know that this driving mechanism, the continents are moving because of the internal convection current. Because of the internal convection current. There is lot of heat energy in the interior. The mantle, there is convection current in the mantle. This convection current is forcing the continents to move, or rather the upper layer of the earth to move. The convection current is forcing the outer layer of earth to move. We know it today because of the internal convection current and the energy, the heat energy in the interior of the earth is forcing the outer layer to move. But at that time there was no such understanding. So in 1928, say 1924 onwards, see in 1928, Arthur Holmes, an English a geologist, he talked about convection current in the mantle. He came up with the idea of convection current in the mantle in 1928. Wegener heard about it. Wegener even suggested that could also be a reason, but he did not know anything about that. It was only in the beginning, only in 28 for the first time it was said. But even though this idea of convection current in the mantle came in 1928, it was not taken as an evidence or anything, because the very idea that the continents are moving was rejected by the rest of the scientists at that time. So there is no question of accepting what Wegener said. But even Wegener heard about it. Wegener said this could be a reason. But anyway, he was not heard, or other people rejected him. People rejected him as a mad scientist. So that is why his idea that continents are moving was never accepted and never even looked into. But he wanted to prove that continents are moving. So one of the ideas he did is he wanted to measure the distance between 2 points, one in Greenland and another in, say, two peaks in another in Europe. See, he understood that Greenland is moving away from the Eurasia. So he said that the distance between the two mountain peaks located in Greenland and Europe are increasing. So he made many expeditions to Greenland. In one of the expeditions, the third expedition to Greenland, regarding the study of the he was also a climatologist. He did not have the idea of jet streams at that time. So he wanted to study the upper atmospheric wind movements also. So he was trying to understand this also, the distance between the 2 points. So in one of these, the third expedition in November 1930, while traveling back from the mountain peak called Esmitte, E-I-S-M-I-T-T-E, to the base camp, they met with an accident, some avalanche, the ice slide, and Wegener died in that avalanche. So that is how his continent drift hypothesis came to an end at that time, because there was no other supporter for this theory or this idea. So temporarily there was a relief for the rest of the critics, because he died and nobody to push for this idea. So he was buried in Greenland only at the age of 50 because of this avalanche or this accident. Anyway, so that is how the continent drift hypothesis came to an end for the time being. And then the great economic depression in the world. Then the Second World War came, there was a relative lull period, there was a relative calm, there was no major developments. See, some developments came in the late 1940s, which was known as the Paleomagnetic Studies. Paleomagnetic Studies, meaning old rocks, paleomagnetism. Paleo means old. Paleomagnetism means magnetism of old rocks. Magnetism of old rocks. Then, meantime, by early 1950s, more understanding about the ocean floor. It was thought that Wegener said that ocean floor is smooth and continents can easily drift on top of it. It can easily move across the ocean floor. But it was realized that there are trenches, there are ridges, there are plateaus, there are sea mounts. So, it was for the first time when we started getting a picture of the ocean floor, it was a shock to the scientists that there are so many different landforms. It is not a plain barren surface, or the ocean surface is not, ocean floor is not a plain and barren. There are many landforms. Trenches are there, ridges are there, sea mounts are there. Some of the longest of the ridges are below the ocean. The mid-Atlantic ridge, thousands of kilometers long. It was a shock to the scientific community. Meantime, another scientist, Harry Hess, he came up with the idea that the seafloor spreading, or rather seafloor. See, Wegener did not talk about seafloor, but Harry Hess, in a book, he wrote a book and he said an essay in geopoetry, because he knew what happened to Alfred Wegener, how difficult it was. So, he did not say a seafloor spreading hypothesis like continent drift hypothesis. He did not talk about a seafloor spread hypothesis. He said an essay in geopoetry, and in that he said that the ocean floors are spreading. New ocean floors are created near the ridges, and old ocean floors are destroyed near the trenches. So, he talked about seafloor spreading. So, let me just show you that the seafloor spreading concept. He said because of the convection current in the mantle, you can see that the convection current, the heat energy, the molten material is circulating inside, and near the ridges, the ocean ridge, mid-oceanic ridges, near the mid-oceanic ridges, you see mid-oceanic ridges, new ocean floors are created, and these old ocean floors are taken back into the mantle along the trenches. You can see along the trenches, mid-oceanic ridge. He talked about that. So, Wegener said that continents are not permanent. Now, Harry Hess is saying that the ocean floor is not permanent. He even said that the average life, the average age of ocean floor is not more than 160 million years. And the oldest of them may be 200 million years. The oldest of the ocean floor are found near the trench, and the youngest of the ocean floors are found near the, it is found near the ridges. So, continents are not permanent according to Alfred Wegener. Now, Harry Hess is saying that the ocean floors are also not permanent. In fact, continents once created, it may not go down because it is very light. Ocean floors are constantly recycled. Most of the ocean floors, the average age of the ocean floor is only 160 million years. That was a new revelation. And by this time, scientists were more, they are accepting new ideas. So, by late 1960s, this plate tectonics theory emerged. So, plate tectonics theory is a culmination of various scientific developments, right from the continent drift hypothesis. Then we had this paleomagnetism, old magnetism studies. We came to know more about the old magnetism. We came to know the ocean floor, the understanding of the ocean floor. Then came the Harry Hess's idea of seafloor spreading. So all these developments ultimately led to, by late 1960s, by 1969, a new theory emerged. There is no one single scientist who can be credited for this plate tectonics theory. This theory is a culmination of the understanding of the non-permanency of landforms on the surface of the earth. Nothing is permanent, everything is in a cyclic mode. Continents are not permanent. Landforms, the mountains are not permanent, the plains are not permanent, even the ocean floor is not permanent. Everything is moving, and this ultimately led to the 1969 plate tectonics theory. It is able to explain most of the phenomena on the surface of the earth. Plate tectonics theory today is able to explain the formation of the fold mountains, the mountain system. It is able to explain the formation of the fold mountains. It is able to explain the formation of the island arcs, the islands, the Indonesian archipelago, the Japanese archipelago, the Philippines archipelago, the islands. It is able to explain volcanoes. It is able to explain earthquakes. It is able to explain almost every phenomena on the surface of the earth. It is able to explain tsunami. Almost everything on the surface of the earth. This movement of the movement of the top layer of the earth, which we call lithosphere, because of the internal convection current. That idea, or as a culmination of these, so it's a relatively new idea. Only in 1969 the concept of plate tectonics emerged, but it is able to explain most of the landforms, most of the geophysical phenomena on the surface of the earth. That is the beauty of this plate tectonics.